In this segment, we're going to be talking about how infrared heat moves throughout your home. Infrared heat is different than every other heat source. Coal, gas, kerosene, wood, propane, they're all combustion-based heat. So that means it takes the moisture and the oxygen out of the air. Infrared is the opposite. Infrared keeps the moisture in the air. So infrared works different than every other heat source. Here's a little diagram of a home. If you have a combustion-based heat source here, like your traditional electric ceramic space heaters, or a kerosene heater, or a wood stove, it's going to take the moisture out of the air so the heat will stay close to the heat source and it will be warm right here. The rest of the house will be cold. Infrared works the opposite. You put an infrared heater here, the moisture in the air is a natural conduit for heat. Almost instantly, when the heat comes out of an infrared heater, it goes to anywhere in the house it can get to and heats evenly. This room will be the same temperature as that room within 2 or 3 degrees. It depends on the insulation value of the home and how far away the room is. It's good and it's bad. The good part is that infrared heats evenly. The bad part is, let's say that you just want to heat the living room. It may not do that real well. I had someone come into our facility and a lady had bought one of our heaters a number of years back, and she said, "I have your heater 6 feet in front of me and it doesn't keep me warm." Well, after asking her some questions, I learned that her house was over 3,000 square feet. It was the only heater she had on in the house, and it was extremely cold outside. So what happens? The heat coming out of that infrared heater, the moisture draws it throughout the entire house. The heat doesn't stay there. So she was only 6 feet away from the heater and it didn't keep her warm. That's the downside with infrared. So what she needed to do is put her curtain across the hallway or block off the room so the heat stays in the room, or she needed to buy another infrared heater. One heater isn't going to heat 3,000 square feet in the dead of winter when it's really cold. So because infrared heat works different than combustion-based, we need to keep this in mind as well. The average temperature of the ceiling in a home is 6 to 17 degrees warmer than the floor. But with infrared, the ceiling temperature is only 1 to 2 degrees warmer than the floor. If you're heating with just infrared, the moisture molecules in the air draws the heat in every direction and heats evenly. So if you have a home with high ceilings and you're heating with infrared, you don't want to use ceiling fans because moving air feels cooler than still air. And also you don't want to be running the motor that's spinning the blades because that's using electricity. So if you're heating your home entirely with infrared, you don't want to use ceiling fans. Now you might say, well, I thought infrared heaters were just, space heaters. They were a supplemental heat source. Well, every other infrared heater you can only use as a supplemental heat source because they don't have that one feature that mine does have, and that's called memory technology. If your electricity goes off, when it comes back on, mine automatically comes back on. So you can use mine as your only heat source. We lived in a 3,000 square foot home. We used to heat it with oil. We were spending $3,000 a year with oil. I decided one day to turn the oil furnace off and turn on 3 of my infrared heaters. We started heating our entire house, 3,000 square feet, with 3 of my heaters, and that's all we used to heat our house all winter long. And our electric bill increased by $1,500. So rather than spending $3,000 in oil, we only spent $1,500 in electricity. Infrared heat is the cheapest form of heat there is. It's also the safest form of heat there is. It cannot start a fire.